In this video, I will show you how to perform left shift operation on a given integer number and right shift operation on a given integer number. First, I will open the editor, developer C++. After opening this editor, we have to choose new source file. Then it will allow us to type the program. First, we need to identify what are the required header files that we need for our program. So first, I need the basic header file, that is standard stdio.h, that is standard input output header file. Next, begin the main method. Any operations we need to include inside the main method. So here my aim of the program is to apply left shift operation on the given input number and right shift operation on the given input number. So for that I need an integer number, int n1, declaring this, and I am allowing the user to enter an input value. Before that I am providing a description message. The purpose of the input is enter an integer number, integer integer number. I am applying new line because I want to allow the user to read a number after this message. See, it will slash n means new line. Now I am applying scanf function to read input value using the format specifier %d for a integer number, and I try to read a number, that is n1. So n1 ampersand n1 is used to read a number. Now I want to hold the result of left shift operation and right shift operation. For that I need two more variables. R1 holds the one result, R2 holds the second result. So what is this R1 and what is this R2? I will explain. R1 is assigned with an input number. I am trying to first apply right shift operation. Right shift operation on the given number, that is n1. After applying the right shift operation, I want to test what is the result that is holded by R1. So I want to display some description message, left shift operation result. So the result is stored in which variable? R1. So here we need to specify the modifier, format specifier, that is %d is the format specifier for integers. Now similarly I want to apply left shift operation on the same input number, that is n1. Left shift, this is the left shift symbol and this is the right shift symbol, and this one is nothing but how many times we are applying right shift operation on the given input number n1, how many times we are applying left shift operation on the given input number n1. After this again I need to print the same message like the previous one. So instead of typing, just I'm copying that statement. I will paste it here. Just I will change the meaning, description message, that is right shift operation of the result, and this time the result is holded by another variable R2. So we need to save this program first. So you can click on save button, then it will allow. I am already in the C lab folder. This is about bitwise operators. So bitwise demo1.c. So by seeing the name of the program, I should recollect what is the exact aim of the program. Such a way we have to assign a meaningful file name for our programs. So once I open this file after some days or after 1 month, by seeing the name of the file, I should recollect the aim of the program. So I am assign a name that is called bitwise bitwise demo1.c. Now, how do we run this program? We have multiple options here. If I click on execute, I can use this F9 button in my keyboard for compilation, F10 button in my keyboard for run, or I directly click on here, or I can use the same symbols that are also displayed here. Just by clicking on this symbol, first it will display list of errors. If there are no errors, it will display like this: errors are 0, warnings are 0. So my program is syntactically correct as per the syntax rules of the C language. Now I want to test whether my logic is correct or not. So I will assign a number, that is this one, 80. So left shift operation result is 9 and right shift operation result is 6. If you observe, both the results are displayed in a single line. Why? Because I forget to give slash n after printing the result here. Because of that, what happened? Both the results are merged together, so it makes us confused. So I want to separate them. So I applied new line now. Once we made any changes, immediately we have to save it. Then again, we have to recompile the complete program once. There are no errors again. No errors, no warning. So now I need to run this one. Suppose if you observe, if I given the input number 18, what happens when I'm applying left shift operation? 18 becomes 9. That means exactly half of the given number. When I'm applying right shift operation, then it results 36. That means it doubles the number. See, in bitwise operators, actually we have one file. I will open that file. I will open one input file. I will show you that. Handouts. See here, I am. Yes, I created a document to explain about exactly how the bitwise operation will work on an integer number. I already drawn some sketches here using some symbols that are available in the Word document. See, so left shift operator and right shift operator. See, in our example, first I applied right shift operator, I think. I will open the output. Yes. If you observe here, first I need to explain the left shift operator, this one, that which results 9. Our input is 18. Now you can check it here. What is the equivalent binary value for 18? The equivalent binary value for 18 is 10010. You see, this is the equivalent binary representation for the decimal number 18. If you see, the power values starts here, magnitude values 2 power 0, 2 power 1, 2 square, 2 cube, and 2 power 4. This is 2 power 4. Now, wherever ones are there, just add those magnitude values. At this place, 1. At 16, 1 is there. At 2, 1 is there. So, 16 plus 2, how much? That is 18. I hope you all of you know about how do we convert a given decimal number to binary. So, based on that, we obtain this 10010. Now, what is our aim of the operation? We are going to apply bitwise operator right shift. Right shift means each bit will be moved one position right side. If you observe here, this one is moved to here, and this 0 is moved to here, and the next 0 is moved to here, and next one is moved to here, and there is one more bit left out, but there is no place to move it, because when you are moving right side, this is the last position. 2 power 0 is the last position, but when you, so but there is no further place, so we have to discard this bit. But coming to the left side, there is a place available, so we have to fill it with 0. We have to fill it with 0. So after moving this bit here, again this position becomes blank, so that left out position is filled with 0. Now again, if you calculate the magnitude values, 2 power 0, 2 square, 2 power 1, 2 square, 2 cube, 2 power 4, that is means 16, 8, 4, 2, 1. Now wherever ones are there, just you add them. At 8, 1 is there, and at 1, 1 is there. So 8 plus 1 becomes 9. So our input value is 18 and the output value is 9. That means indirectly it divides the given number by 2. Means it is equally divides the given integer number into two equal parts. 18 off of the equivalent value of the 18 is 9, like that. Now the same thing when you are applying right shift operation. What is the output we watched here? When you are applying the right shift operation, 18 becomes 36. That means indirectly we are multiplying, we are doubling the value. So 18 double value means 36. So how? I will explain again by opening this document. If you see here, again our input number is 18 only. So what is the conversion? Equivalent decimal conversion, binary conversion for the given 18? 10010. Previously we done left shift operation. Now I am going to do, sorry, previously we done right shift operation. Now I am going to do the left shift operation. If you observe, I want to move each bit one position left side. So like this one, the leftmost bit, the most significant bit is moved one position left side, and this 0 will come here, and the next 0 will come here, next one will come here, and next 0 will come here, but here this space is left empty. The rightmost bit or least significant bit is left out 0, left out empty. So the empty bit again filled with 0. Okay, now the latest values of magnitude values are, if you write like this, 1, 2, 4, 8, 16, 32. So wherever ones are there, just you add them, 32 and 1, 4. So 32 plus 4, that becomes 36. So if you are applying left shift operation, you are indirectly performing multiplication. Suppose if you see here, 1 is there. This 1 becomes 2. This 2 becomes 4. 4 2 is 8. 8 2 is 16. 16 2 is 32. So when you are moving left side, indirectly you are multiplying. When you are moving right side, this 16 becomes 8. 8 becomes 4. 4 becomes 2. 2 becomes 1. That is the reason when you are moving 18 by one step right side, 18 by 2 means that is equals to 9. When you are moving left side, 18 multiplied by 2, that becomes 36. So in this way, we can apply right shift and left shift operations on the given number with the help of this one. So what is the meaning of this one? This one meaning is how many times we are applying the left shift operation or right shift operation on the given number. Suppose if I change this to 2, what will happen? Our input number is 18. 18 right shift means 18 right shift by 1 means 9. Again 9 right shift by one more time. Then some result will be displayed. Similarly, this one 18 becomes 36, 36 becomes 72. If I change it to 2, watch the changes. Again, once we made any changes, immediately have to recompile after saving, then run the program. Again, give the same input number. This one's 18. When you are applying left shift operation, when you are applying left shift operation or right shift operation, the values are like this. One minute. So actually, this is which operation? This is right shift. So here we need to change this one. The symbol is saying that it is towards right side, so it is right shift operation, and this is left shift operation. When it is towards left side, then we call it as a left shift operator. Okay. There's a small correction in the output description message only. Logic is correct. Logic, there is no change in the logic. Only changes in the. Again, I recompile. Again, rerun the program again. Now you can observe. When I'm applying the right shift operation, 18 becomes 4. But why it becomes 4? Actually, 18 off is 9. Okay. Previously we got 9. And when coming to the left shift, previously we got 36. But in place of 36, this time we got 72. In place of 8, we got 4. In place of 9, we got 4. Why? Because this time we are applying the same operation two times. N1 right shift 2 means we are applying right shift operation two times. If you are applying only one time, 18 becomes 9. Then half of the value of 9 is 3 point, half of the value of 9 is 4.5 something. So that truncates the fractional part. It results only integer part, that results 4. Now coming to the left shift operation, 18 becomes double value is 36 one time. But here we clearly mentioned that two times we need to apply left shift operation. So one more time on 36, again you have to apply one more time, then 36 becomes 72. So in this way we can apply left shift operations on right shift operations the given number. So what I did, very simple, I declared one input number, and to store the left shift operator or right shift operator, I declared two more variables of integer type. That is the reason while declaring it as integer, even though here it generates 4.5, it truncates that 0.5. It generates only 4. Why? Because I declared that value as integer. So for reading a number, I'm using this printf and scanf combination statements. And after applying right shift operation two times, immediately I'm printing the result. After applying the left shift operation two times, immediately I'm printing the result.